Hi everyone, today I'm going to show you how to make the protein synthesis foldable. This is what it looks like as a finished product. To start, what you're going to need is a ruler if you would like, a piece of paper. I'm using orange because our checklist for the unit was orange, so I'm matching for this unit. And then I have my codon wheel of amino acids. We're going to be using this. Mine is color coded. I just wanted to throw this out there that I colored the inside circle where you start green, the middle circle, which is for the second letter in a codon, blue, and then the last circle on the outer edge as pink for the third letter in the codon. If you would like to do that on your codon wheel of amino acids, feel free to do so. I also put a key down at the bottom to help me remember where to start for which letter in a codon. But to get us started, I'm going to push this out of the way and just use my orange paper and my ruler and my pen. We're going to start this foldable by folding the paper the long way. Some people like to call this hot dog style. And then I'm going to unfold and fold the outer edge, actually both outer edges, in towards the middle center line. So that crease that I just made. So there's one edge folded into the center, and then the other outer edge folded into the center. So now when I unfold it, I have 4 columns, but we're actually going to keep this folded like this. So my outer edges are going to stay folded in towards that center crease line that we had. What I'm going to do is also set up a spot for me to write across the top and across the bottom. About an inch or so from the top and the bottom, I'm going to draw a line across the top and on the bottom. This is for me to just jot down some notes as I'm doing this foldable. All right, on the outside, the side that's on the left side, so technically we're starting on this one, but it's facing me, so it's this way. We're going to label one of these as DNA. And then the other side, complementary. So at the top of my foldable, I have labeled DNA and complementary. On the DNA side, you're going to write down 9 letters using A, T, C, and G, so the DNA nitrogen bases, down this column. So I'm just going to start with A. 1, 2, 3, 4, 5, 6, 7, 8, 9. So now I have 9 bases that I wrote down on that one side. I hope you guys can see that. On the other side now, the complementary side, I'm going to write the complementary base pair that matches whatever is here. So if I have an A here, T, G to C, T to A, C to G. Okay, so now I have my original DNA side, my complementary strand. Down at the bottom, I'm just going to write a few notes about what DNA's purpose is. So maybe on this first side, I'm going to write that DNA makes proteins from its code. So DNA makes proteins from its code. And then on the other side, maybe I'll just write down that proteins basically make you. So there's a few little notes on the bottom there. of my front side where I have the DNA strand and the complementary strand. Now on the inside, so I'm going to flip this towards me, on the inside we're going to do another line across the top and across the bottom so that we can have spots to write notes. So about an inch from the top and about an inch from the bottom, I'm going to draw a line. Ooh, that was not a very good line. Ah, there we go. All right, same thing on the bottom. So now I have a line across the top and across the bottom where I could write some notes. On the leftmost column, which technically looks like the right in the video, but my left and your left side column, so this side, we're going to do DNA replication first. And to replicate something means to just kind of copy it. So we're going to copy our original DNA strand from the front side. So DNA replication. And for that column, so DNA replication, I'm going to use the DNA strand that I originally started with. That's on the front side. So that was, in my case, A, G, C, T, C, T, G, C. And the only reason why I could do that without looking back is because I could actually see through the paper. So my original DNA code is replicated on the leftmost column. Now we're going to go through the process of protein synthesis by taking that DNA strand and making the messenger RNA. So this is transcription. That we're going to do in the next column. We might want to make some little notes at the bottom of this column. Maybe something like mRNA is a copy of DNA. And that copy can leave the nucleus. Because remember, DNA cannot. So at the bottom there, I have that mRNA is a copy of DNA. That copy, or the mRNA, can leave the nucleus. So now, in this column, I'm going to make the strand of mRNA that is complementary to my DNA strand that's here in the DNA replication column. Now remember, in mRNA there's no such thing as T's, or thymine, and U's replace it. So the A's that I had in my original DNA strand in the leftmost column here, those pair up with U instead of T. And where I have an A further down, a T, I still bond that to A. Or pair it with A, I should say. So I made my mRNA code. And then that mRNA strand leaves the nucleus, and in my third column, we go through the process of translation, which makes tRNA, which is responsible for going to find the amino acids to make the protein. So this time, in the tRNA column, we're still going to make the complementary strand to the mRNA. And because it's an RNA, remember that there is no T's, there are U's. I just realized there was a glare on the paper. So now I have my complementary tRNA. On the bottom, I'm going to write some notes in my column about translation. I think I'm just going to sum it up as it uses the mRNA to attach amino acids making a protein. All right, now we have one last column left, and that's the column that we're going to list our amino acids. So at the top of that column, I'm going to write amino acid, and that eventually makes the protein. So I'm over here. Okay, this is where we need to remember what a codon is. So a codon is a set of 3 letters that is used to match amino acids. Codons are in mRNA, so the mRNA strand is actually the codon part. tRNA is the anticodon. The tRNA anticodon is what gets the amino acid matched up to the code here from mRNA. So this is technically our codon. So I just kind of drew a little bracket around the first 3 letters, and I'm going to write right here next to it that that's technically a codon. And that in the tRNA, we have the opposite, that's an anticodon. So I hope you can see what I did there at the top. So we have codons in the mRNA column, we have anticodons in the tRNA column, and I'm actually just going to keep going down my line and marking off my codons. So I have 1, 2, 3, that's my first codon. 1, 2, 3 bases, that's my second codon. 1, 2, 3 letters, that's my third codon. These are all the anticodons. To fill in the amino acid column, we use the codon wheel of amino acids. And I showed you earlier that I color-coded mine. And using my code here, I'm going to figure out the amino acids. So for my first codon in the mRNA column, I have a U, U, C. So I use my codon wheel, starting with the first letter, which is green. So U, biggest, to medium, or the blue, second letter, which was a U. And then third letter, which was a C. So my amino acid is right here, alanine, I'm sorry. Reading upside down is not good. So there's my first amino acid. My second amino acid, I'm going to use my codon wheel again, use my second codon in my mRNA strand, which is a GAG in my case. It might be different in yours. I start in the inner circle and work my way out to the outer circle, and I find my amino acid on the outside. Go ahead and try and do the last one on your own, and I will be checking these when I get back to class next time.